Alright, let's try adding a couple of vectors together. We've got two vectors, 19 meters per second at 0 degrees, 37 meters per second at minus 78 degrees. Not given any north, south, east, west direction, so we're dealing with the mathematician's convention. And the game plan, as always, break up each of the vectors into its components, add the components to form the component of the resultant vector, and then do a little vector addition problem to form the final vector from its components. So the first one, we got 19 meters per second at 0 degrees. That's going to be an easy one to break up into components. So go ahead and draw the vector component diagram, x direction, y direction, and draw that one on there. At 0 degrees it would be in that direction. These are velocity vectors. I think I'll call that vector v1, and its length is 19 meters per second by inspection. v1x is 19 meters per second, as the vector is only along the x-axis, so the entire length is its x component. And v1y is 0. Alright, let's take a look at that second vector. Draw a vector component diagram for it, or the x direction and the y direction. And this one is at minus 78 degrees. Okay, in the mathematician's convention, we define the angles to be positive as counterclockwise from the x-axis. So minus 78 degrees means that it's 78 degrees clockwise with respect to the x-axis. So I'll call that V2, and in magnitude it is 37 meters per second. V2x would be this vector. I draw it just far enough so that if I draw a vertical line, a vertical arrow, it'll make it right to the tip of the second vector. A little bit sloppy in the diagram. They should actually meet tip to tip there. This I'll call it theta 2, given as 78 degrees. So here I'm forming a triangle where the angle in that triangle is 78 degrees. I've used the negative sign already to indicate that this should be over here rather than up there. But this opening between these two lines is just 78 degrees. And I use some trigonometry to find out what V2x is, V2y. Technically, it might fall under the heading of plane geometry, but I'm using the trigonometric functions. I think I'll go with V2x first. V2x divided by that given V2 is the adjacent of this triangle that I formed, divided by the hypotenuse. Adjacent over hypotenuse is the cosine of the angle. So V2x is V2 cosine of theta, or V2x is 37 meters per second times the cosine of, and the theta I'm dealing with is theta 2, so that's the 78 degrees. Evaluating that on the calculator, I get 7.69 meters per second, and I'm carrying one extra sig fig. The value is given to 2 sig figs. I'm going to carry 3 in my intermediate results and then quote the final answer to 2 significant figures in keeping with the number of sig figs given. Let's work on V2y. The formula involving V2y is V2y over V2, which would be, with respect to this angle theta 2, that's opposite over hypotenuse, and that's the sine of the angle, which is theta 2 in this case. V2y is V2 sine of theta 2, which is 37 meters per second times the sine of 78 degrees, and to 3 sig figs, that is 36.2 meters per second. Now I'm working with a triangle here. This triangle right in here. I recognize the sides. The idea, when I'm dealing with this part, I'm working with a triangle, even though the sides were originally vectors, and I want to just use the length of the sides when I'm using my trig functions, like opposite over hypotenuse. And so here, V2y, the y component is actually, because it's in the negative y direction, I would think of that as a negative value. I've substituted a positive value in there. I want to emphasize that I'm just dealing with the length of the leg of the triangle in this part of the problem by putting absolute value signs around it. And then I'm going to take them off and at the same time incorporate that information about the fact that this V2y component is pointing in the negative y direction. So up here I was dealing strictly with magnitude. Now I've tacked on the direction. The y component of this vector, V2, is minus 36.2 meters per second. So that tells the reader 36.2 meters per second long, and it's pointed in the negative y direction. Alright, now we're in a position to go ahead and add the components together. We'll get the total vector x, I'll call it just v for the total vector, and the x component is v sub x is going to be v1x plus v2x. So x component of the total vector is going to be the 19 meters per second that we found for v1x plus 7.69 meters per second that we found for v2x. So adding those two together, I get for the x component of our resultant vector 26.7 meters per second, and I've rounded it off to the first place after the decimal. Get 3 sig figs. Our final answer should only have 2. Vy is v2y. Oops, I wanted to do it in order. v1y plus v2y. So v1y plus v2y. Remember, v1 was strictly along the x direction, so we found 0 for v1y and a minus 36.2 meters per second. Oops. For v2y. So vy is just minus 36.2 meters per second. Now we've got the components of the resultant vector. We're supposed to do a vector component diagram and establish the total vector in magnitude and direction. So we'll get the x direction, the y direction. We'll get a vector component diagram that looks like this. So Vx, we march along here, certain distance representing the magnitude of Vx, which is the 26.7 meters per second. And then we have to go in the negative y direction, a distance that's a bit greater than that one, representing a velocity vector of magnitude 36.2 meters per second. So these are absolute value signs, just the size of that value without the sign information. So our total vector V is the one that extends from here to here. It's at some angle theta with respect to the x-axis. And I use this diagram directly. I'm going to use my trig functions. I deal with legs of the triangle that have positive values. When somebody says the tangent is the opposite over the adjacent, what does that mean if the opposite has some negative length? We're not even going to think about that. We always will deal with what we're familiar with, triangles that have sides of certain lengths, and the lengths have meaning to them. And in this case, the length of this side is 36.2 meters per second. So let's never write something like the tangent is equal to some negative value divided by a positive value, or a positive value divided by a negative value. But look at the triangle and make sense of it using your understanding of plane geometry and your trig functions. So what I can say is, looking at that triangle, the tangent of the angle theta is that Vy over Vx. And solving for the angle itself, I'll take the arctangent of both sides. I did that to get rid of the tangent here. The arctangent of the tangent is just the angle itself. And then on the right, I go ahead and take the arctangent of the right. So theta, I go continue on down here. Theta is equal to the arctangent of the 36.2 meters per second divided by 26.7. So put those values in the calculator, evaluate, and I get an angle of 54 degrees, rounded off to 2 sig figs because we were given values to 2 sig figs, and this is a final answer. Now, the magnitude of the vector, and that's this angle. I'll have to interpret that in quoting the final answer to the reader, but I'll use Pythagorean's theorem to get the magnitude of this total vector v. V is the square root of Vx squared plus Vy. Whether I use absolute value or the magnitude itself doesn't matter, but squared. So again, I am looking at it as legs of a triangle using Pythagorean's theorem, not some memorized formula for magnitude of a vector. So V is 26.7 meters per second all squared plus 36.2 meters per second all squared, and then everything I just said under the radical. Evaluating that, for V I get 45 meters per second, rounded off to 2 sig figs. So our final answer for V is, the vector V is 45 meters per second at an angle of make it look a little bit more like 54 degrees. 54 degrees below the x-axis. If you wish, you could write that as 45 meters per second at minus 54 degrees. This is going to be my final answer, but other ways you could have written that are V is equal to 45 meters per second at minus 54 degrees. By the mathematician's convention, that means clockwise from the x-axis. You could have also written it as V is equal to 45 meters per second at would be 360 degrees minus 54 degrees. I get 306 degrees. The positive sign means counterclockwise with respect to the positive x-axis, and indeed that is 54 degrees all the way around. This method, when you're doing it out longhand, is the easiest, I think, to convey to the information to the reader. The reader doesn't have to say, okay, mathematician's convention, minus sign means clockwise. You can just see it right there. This, by the way, is the way engineers generally write it when they're writing things out longhand. So I like that. This one, I think, conveys the information most easily. But these are all, perfectly acceptable ways of writing your final answer.